We're going to look at circles a little bit deeper. We already know about diameters and radius. All right. Diameter is at two endpoints and goes through the center, and radius is at the center and goes to an endpoint in the circle. But now let's look at a chord. A chord, what the definition of a chord is a line that's it's a line segment whose endpoints lie on a circle. So these endpoints are on a circle, but a chord doesn't go through the center. That's a unique chord. That would just be referred to as a diameter. But if it doesn't go through the center, it's a chord. A secant, definition of a secant, is a line that intersects a circle at 2 points. And so this line intersects the circle at 2 points, but notice it keeps going. The difference between a secant and a chord is a chord stops at the endpoints, it's a line segment, and a secant keeps going. And then the last one is a tangent. What a tangent is if you have a radius, or a circle, the center of a circle to an endpoint, a tangent line is a line that this is a line in the same plane as the circle that intersects at exactly 1 point in the circle. And when you have a tangent line to a radius, what that means is it creates a perpendicular angle. But a tangent intersects at 1 point on the circle, which is really hard to draw. Now let's look at some theorems. Then I'll describe them with kind of a drawing. Theorem 43-1 says that if a diameter is perpendicular to a chord, then it bisects, that's key word, the chord and its arcs. So we look at example 2a to show what 43-1 means. Okay, well we're trying to find x here. And 43-1 says if a diameter is perpendicular to a chord, well, right here we have a diameter and a chord, and they are perpendicular. Well, what happens then? Then it bisects the chord and its arc. Bisects means cut it in two evenly. So that means this line is equal to this line. Therefore, if this is 3, x is also 3. And that's as easy as it gets right there. 43-1. Theorem 43-2 is basically the converse. It says if a diameter bisects a chord other than another diameter, then it is perpendicular to the chord. So here we have a diameter bisecting a chord. It is not another diameter. We're intersecting a chord. Therefore, we know that these lines are congruent. And if these are congruent, we know that it must be perpendicular. So if it said find angle ORP, well, angle ORP would be 90 degrees. But it's kind of the converse. So that's what you have when you have chords and diameters intersecting. Let's look at example C. This one can be one that can be a little tricky. It wants to know how far is line AB, or chord AB, from the center P. And then it gives us the measurement for the diameter 14, and the measurement of AB is 8. So diameter, let's just write down what we know. And AB equals 8. How can we figure out what this line is? That's what we got to find the measure of. Well, what we can actually do, if we just have to think back to what we know about circles, what we could do is create a triangle, and we could go from this point to this point. Now, what do we know about this line? It's at the end point of a circle and goes to the center. Well, automatically we know that that is a radius. That's the definition of a radius. Kind of wrote that R weird. And do we know the radius of this circle? Well, yes, we do. Radius is simply 1/2 of the diameter. So therefore, the radius equals 7. Radius is 7. Now, what else do we know? Well, theorem 43-1 that we just looked at says if you have a diameter and a chord, what we can do is create and when we create a perpendicular line here, because we're going to draw this line perpendicular to the center of the circle. When we do that, we divide these equally. So therefore, this part of the triangle would be 4. So what I can say is we have a hypotenuse of 7, a bottom leg of 4. I'm just moving this triangle here. And now we need to find, I'll call it x. And so now we can simply use the Pythagorean theorem. 4 squared plus x squared equals 7 squared. 16 plus x squared equals 49. Subtract 16. 33 equals x squared. Square root both sides. So square root of 33, or whatever decimal that is, would be your answer. Let's see if the book puts it in decimal form. Yeah, it says square root of 33 is 5.74. But it did not clarify. Oh, it did. It wanted it to the nearest hundredth. So there's your nearest hundredth of an inch. And so that is how you do solve for these triangles. Just remember your theorems, 43-1 and 2. When you got the diameter and the chord, and you draw a perpendicular line, it bisects the chord.